these are not actual factoring. It's just an organizational process in the way that you want to remember. So remember your big diamond, or I call this X. Some people call it stars as far as other math teachers. But so the multiplied of your left and right, and then the add goes in the bottom. So -2 times a -11 gives me a +22. When I add them together, I get a -13. So same thing for this one. So multiply at the top, add at the bottom. So -4 and a +1 multiplied together is going to give me a -4. If I add them together, that means I owe you $3 and then I pay you $1. Then I still owe you 3, so that's negative. And you know it's going to be negative because the 4 is bigger than 1 and it's negative. So if the larger number is negative, when you add or subtract them or add them, then it should be negative when you're done. 5 times 7 is going to be 35. 5 plus 7 is going to be 12. And then when they start to shake it up, this is where if you get really good at doing these, your factoring ideas will be a lot easier, your thought process, because this is how you will set up your star or your diamond for factoring when A is equal to 1. So I multiplied 9 by something to get 45. So what did I multiply 9 by to get 45? So that's going to be 5. And then when I add them together, that's going to be 14. So if I'm given the number on top, it's what did I multiply together to get that? So like number 18, what did I multiply -7 by to get 14? Let's see if anybody can tell me. What did I multiply -7 by to get a +14? All right, is it a positive or -2? -2. Good job. Because negative multiplication gives you a positive, right? And in this case, it really matters. And I know in a lot of classes, and every year I have students that go, well, you know what I meant, 2 and -2. And my argument is if you have $2 or you owe somebody $2, because I always think of negatives as you owing money, which is really important. Most of us don't want to owe anyone money, and you much rather have money. So if you have $2 versus owing people $2, it kind of a mute argument at that point that they're close enough, because it's not. If you owe somebody $100 or you have $100, your day is quite different. If I add this -7 and -2, that means I owed you 7 and then I owe you 2 more, so I owe you 9 altogether. This is exactly what you need for factoring. So that's why we're working down this column again. And if you're paying close enough attention, this is the assignment you turned in, and you can go and fix it if you did not do these right. What did I multiply together that will give me a -15, but add together to give me a +2? So I don't know about you, but every time I see 15, I think 3 and 5 in general. It's just one of the ones that I think of. I like to put my big number to the left, usually small number. I need it to be a negative answer when I multiply them, but add together to give me a positive. And so since we're adding to get a positive, the larger one should stay positive and the second one should become negative. And then that would be 5 times a -3 gives me a -15, and 5 plus a -3 gives me a +2. So number 26, what did I multiply together to get 7 that I would add or subtract to get -8? So 7 is a prime number. The only thing that you can multiply together to get 7 would be 7 and 1. So that one's pretty easy. Now, would that 7 and 1 remain positive, or should I make one of them or both of them negative? Yeah, they both become negative, exactly. Because then when I add them together, I get the -8. And then when I multiply them together, I get the +7. So again, just a brief review of your diamond math problems, which probably felt a little ridiculous and not completely understanding why you're doing them. But it absolutely directly relates to factoring when A is 1. And when I say A is 1, that's relative to AX squared plus BX plus C. So A is the number in the very front. So if your leading coefficient, the number in the very front is 1, all you're going to do is diamond method almost every time. Okay. So as soon as it's a trinomial, so it's 3 terms, 1, 2, 3, I would say try it. Not every trinomial is factorable, but right now we're practicing factoring, so these are factorable. You're going to put your C value, A times C, in the front, at the top, so that's -60, and then a 4 at the bottom. So what did I multiply together to get 60, but adds together to get 4? Now, these numbers are a little bigger than some in your video. So multiply to get 60, add to get 4. So multiply, add. So if I have 60, I have 1 and 60, 2 and 30, 3 and 20, and you're just going down the line. 4 and 15, 5 and 12, 6, 10, 7's no good, 8's no good, 9's no good, and then we hit 10 again. So that means we know we have all of them. If you have a TI 83 or 84, if you type 60 into the y equals, so go to y equals and type in 60 divided by x, you'll get all your factors. And that is, my battery's dying, sorry. 60 divided by x, and if I hit second graph, all my whole numbers here, so 1 and 60, 2 and 30, 3 and 20, 4 and 15, you can check your numbers here, 6 and 10, and then we start getting into decimals until I see 6 and 10 again, and 5 and 12 again, but we don't need to repeat them. So when I put them together, I need to have a positive 4. So 60 and 1 is going to be 61 or 59. 30 and 2 is going to be 32 or 28. If one of them was negative, that's where I would get the 28. So adding or subtracting at this rate. So 3 and 20 would be 23 or 17. 4 and 15 are going to be 19 or 11. If I added it or subtract it. 5 plus 12 is going to be 17. 5 from 12 is 7. 6 plus 10 is 16, and then 6 from 10 is going to be 4. And the number you're looking for is that 4. So this is going to be the set of numbers that are going to work, that multiply to give me 60 and add or subtract to give me 4. So I'm going to put the big one in the front, small guy in the back. I need a negative 60, but I need it to add together to give me a positive 4. So where will I put a negative? On 10 or 6? Yeah, it's got to be a negative 6 because that means I had $10, I spent 6, I still have 4. And then from here, you're going to open up your set of parentheses, x plus 10, because we know it's a positive 10, x minus 6. And now you have factored that trinomial. Now, working towards the end of the week, you want to be able to solve these. So again, I can't say this enough. These are the factors. If it asks for the solutions or the zeros, the x-intercepts, or anything of that nature, you still have to do this portion first, but then you're going to push it a little further. So if it asks for the solutions or answers to this quadratic, we're going to do x plus 10 equals 0 and x minus 6 equals 0. And then we're going to solve for x. So we need to move the 10 over to get it away from that x, and it's positive. So we're going to subtract 10 from both sides. So x equals negative 10. We're going to move that 6. It's a negative, so we're going to add. So it's going to be x equals positive 6. So the solutions are negative 10 and positive 6. So factors are x plus 10. Solutions are, x plus 10, x minus 6. And then solutions are negative 10 and 6, positive. And this is also x-intercepts is another word they use for it, kind of like how they have 100 words to ask for slope. Solutions, x-intercepts, roots, zeros, and answers, I guess, would solutions, yeah. So all of these numbers are referring to these. If it asks for factors, that's what we've done. And I'm pushing a little bit further because you guys are in live time class and hopefully you did your work from today too. So you've done some factoring. All right, so factors, solutions. Solutions are in 2 days. We're just pushing a step further. Alrighty, so we have x squared minus 5x minus 50. A is 1, so we can go ahead and start our big star or our star. I'm going to put c, so negative 50, and then negative 5. What two numbers could I multiply together to get 50, but add or subtract to give me 5? So multiply together to get 50, add or subtract to get 5, and in this case, they're both negative. So you have 1 and 50, 2 and 25, 3, 4, 5, and 10. 6 does not go in there, I don't believe. Nope. If you get a decimal, then that's not 1. So again, we can go to y equals and put in 50 and then hit second table. We got 5 and 10, 10 and 5, so we're done. 5 and 10, then it repeats again but switches 10 and 5, so we know this is our list. 1 and 50 are going to give me 51 or 49. 2 and 25 will give me 27 and 23. And then 5 and 10 will give me 15 or 5, depending on how we use our positives and negatives. We need a 5, so we're going to use 5 and 10. So we're going to put a 10 and a 5. One of them needs to be negative because it has to multiply to give me a negative, and then it has to come together as through addition and give me a negative as well. Should I make the 10 or the 5 negative if I'm ending with a negative at the bottom in my B place? Yep, exactly. So if B is negative, at the very least, the largest one is always going to be negative between the 10 and the 5. So from here, we have x minus 10, x plus 5. So saying it again till blue in the face, these are the factors. So if it says to factor the quadratic, that's it. That's all you have to do. And then if it says to solve or find the solutions, x-intercepts, roots, or zeros, you're going to take your factors. So x minus 10 equals 0, and x plus 5 equals 0. And then we're going to solve both of those equations. So quadratics are parabolas. They look like a U, whether they be positive in that case or negative is a sad face. So positive is happy, negative is sad face. So these are where this graph touches the x-axis, is what the solutions are. So we're trying to get x by itself, so we're going to add 10. So x equals 10. Minus 5 across the equal mark, so we're taking the inverse. X equals a negative 5. So the solutions, zeros, x-intercepts, roots, or the equation, the quadratic equation solved, the two numbers you can use is negative 5 and 10. So those are your solutions, right? So solutions, solutions, solutions. Number 3. So A is 1, so we can start our star. C goes to the top, B goes to the bottom. I'm going to give you a minute and see if you can figure out what two numbers do I multiply together to get 36 that will add or subtract to give me 13. So what two numbers can I multiply together to get 36, to add or subtract to give me 13? So 1 and 36 for sure. 2, 3 and 12. Yep, I see 4 and 9. 5's no good. 6 and 6. 7, 8, and then 9 and 4 again. So hopefully you're starting to see 36 and 1 are never going to give me 13. 3 and 12 are going to give me 9 and 15. 4 and 9 look really good. So I'm going to put 4 and 9. I will say be careful and make sure you check through your list if you're taking the time to make the list, because some of the trinomials, there's more than one pair, and it really determines which one you make negative versus positive as well. In this case, it's a positive 13 and a positive 36, so they're both going to remain positive. So x plus 4, x plus 9. And so again, if it asks you to factor, you're done. This is it. You just factored. The factors are x plus 4 and x plus 9. They will ask you to solve or find the solutions, the x-intercepts, or the zeros. So that means I'm going to take that x plus 4, set it equal to 0 and solve for x, and then x plus 9, set it equal to 0 and solve for x. So we're going to get x by itself. We need to move it across the great divide. So as it switches, remember that's like subtracting from both sides because it is positive, and it needs to have the inverse to move across the equal marks. Again, a positive 9, so to move it over, we're going to subtract 9 from both sides. X equals a negative 9. So our solutions are negative 9, negative 4. And so those are our answers, or our zeros. X-intercepts, and I'm just saying them all so you remember them, roots, and solutions. oops, that's a fail screen, sorry. Zeros, x-intercepts, roots, and solutions. So number 4, I have x squared plus k minus 42. So a is 1 again, so we can just stir our big X. So negative 42 at the top, because c goes at the top. There's a 1, because there's an imaginary 1 in front of every variable, right? 1 at the bottom. So what two numbers can I multiply together to get 42 that will add or subtract to get 1? So their product is 42. Their sum or difference is 1. So product is 42. Their sum or difference is 1. You guys give it a go and see what you think. So 1 and 42, 2 and 21, 3 and 14, or 6 and 7. Which pair can I put together to get a positive 1 of those 4? 1 and 42, 2 and 21, 3 and 14, or 6 and 7? What do y'all think? Yeah, perfect. 6 and 7. Excellent. So I'm going to do 6 and 7. My 1 is positive, but I have a negative outcome of 42. So which one of these two am I going to make negative? 6 or 7? Because a positive times a positive is going to give me a positive, and we definitely need it to multiply to give me negative. Right, so we're going to do negative 6 because the b value is positive, so the largest factor is going to stay positive. So our factors are going to be x minus 6 and x plus 7. Now, this is the same thing as writing this. So their seating or the way they're arranged does not matter as much. It's just a matter of whichever one you choose right first. Because from here, you would either say done, here are my solutions, or you would set them both equal to 0. So these are my factors. Or you'd set them equal to 0 to solve for solutions. So x plus 7 equals 0, x minus 6 equals 0. So if you solve both of those, what are my solutions? Not my factors, my solutions. You guys tell me. Yes, good. Negative 7 and positive 6. Great. Awesome. All right, so the bottom two are multiple choice. I'm going to pause and let you see if you can figure out the answer to those two, and then we'll work them. So try to see, because sometimes I feel like multiple choice is not as beneficial. Sometimes it messes me up, because like in this case, you get real confused about your positives and negatives and things of that nature. So see if you can factor number 5 and number 6. I'm going to give you a minute to give it a go. Messing up is better to mess up now than messing up on like quiz day or EOC day. Cool, cool. We got some answers already. Nice, nice. All right. So looking at the first one, again, A is 1. So in that case, we're good to go with our diamond X star. So I'm going to 28 on the top, 11 at the bottom. They already gave you 4 and 7. So you know it either has to be 4 or 7 or not factorable at all, right? I need them to multiply to give me a positive 28 and then come together by addition or subtraction to give me a positive 11. So that's 7 plus 4 gives me 11. A positive 7 and a positive 4 multiplied gives me a positive 28. So it is going to be plus, plus. So that works there. All right, number 6. Again, 4 and 1. 1's in the front, so we're going to have 4 and 3. So we have 4 at the top, negative, positive 3 at the bottom. We have a little more options in our factors at this point, but hopefully no, it's not 9 and 2, because there's no way 9 and 2 multiply to give me 4 or add to give me 3. So D is definitely off the table. 8 and 6, again, not multiply to give me 4 and don't add to give me 3. So our choices are 4 and 1, and it's deciding which one is negative. We want the larger number to be positive because B is positive, so it's going to be a negative 1. So it's going to be C. All right. Got 4 more minutes. I'm going to keep going. Okay, so now we have problems where A is not 1. But where we're at in the process of our lesson, we need to always check for GCF. So when A is not 1, the first thing you want to do is check for a GCF. Always, always, always. So we have the number 3, 18, 21, and this is negative 18, negative 21. So 3 is a prime number. Ideally, you would like to check the front number and try to get it down to a 1. So if 3 will go into all 3 of them, that would be great. So 3 divided by 3 is 1. Negative 18 divided by 3 is a negative 6. Negative 21 divided by 3 is a negative 7. So in that case, 1 is prime, 7 is prime, 6. So there's not a number that will make any of them better. So we're going to pull out that GCF of 3. And 3 times n squared gives me 3n squared. Negative 18 divided by 3 gave me that negative 6, and then we have the n still there. And then negative 21 divided by 3 is a negative 7. Now, that is factor GCF. If it says factor GCF, you're done. If it says factor completely, we have to keep going, right? So we have to keep going at this point. So we have n squared minus 6n minus 7. So what do I multiply together to get 7? That will add or subtract to get 6. So it's going to be 1 and 7. So on our big star, our X, we have a negative 7, negative 6. It's 7 and 1. My B value is negative, so the big guy is going to be negative. Don't lose your 3 because he is part of the factor. So it's n minus 7 and then n plus 1. So this is factored completely. Factored completely. Now, to solve, it's going to be n minus 7 equals 0 and n plus 1 equals 0. Solve for n, so we're going to add 7 to both sides. N equals a positive 7, and then subtract 1 from both sides. N equals a negative 1. So the solutions are negative 1 and positive 7. So the solutions are negative 1 and positive 7. So again, that's factored completely is here. Solved is here. So factors are in parentheses. Solved is a list of numbers. This number 8, again, 2, 18, 20. You want to figure out what number, because A is not 1. We're going to try 2 because he's in the front. So divide by 2, divide by 2, divide by 2. If that had happened to be a negative 2, you're going to want to divide by negative 2 because you want the front number to be a positive 1 if you can manipulate it to do so. So that's going to be n squared because that's a 1 in the front if I factor out a 2. And then negative 18 divided by 2 is going to be a negative 9n. Negative 20 divided by 2 is going to be a negative 10. We have factored the GCF, but to factor completely, we're going to now put our C value at the top and our B value at the bottom. So what did I multiply together to get 10? Add or subtract to get 9. So it's going to be 10 and 1. One of these has to be negative because our B value is negative. And again, when B value is negative, the big one is at least going to be negative as well. So again, we have hold on to our GCF, n minus 10, n plus 1. That is factored completely. And then we're going to solve just to practice solving. So finding the roots, the zeros, the solutions, and the x-intercepts is when we take our factors and set them equal to 0. So add 10, n equals 10. We're subtracting 1 because that's a positive 1, so n equals 1. So our solutions are going to be 1 and 10. Our solutions, x-intercepts, and zeros, I think I'm all again, solutions, x-intercepts, zeros, roots, are all those, that 1 and 10. All those words mean this guy right here. So these are our solutions.